Hey y'all. Let me move this. Okay, I think it's good enough. Today's lesson is about representing relationships and writing equations. Representing relationships and writing equations. We're still writing equations. We've talked about slope, we've talked about intercepts. And so a few important things here is an equation, a linear equation. Notice the root word is line. A linear equation is an equation with an equation with, I'm like, an equation with a graph that is a straight line. I didn't know if I was defining proportional or non-proportional here, but an equation with a graph that's a straight line, that's a linear equation. And there are different types of linear equations. We've talked about slope-intercept, point-slope, standard form. And those are all types of equations that are linear. And then we've talked briefly about the differences between proportional and non-proportional. So I just want to review that with you. And the differences between proportional and non-proportional are various, and they could be things like proportional is going to go through the origin, and non-proportional. A proportional relationship also is linear, and sometimes non-proportional, so they don't not have to be, no, that's not right. Don't have to be linear. An example of proportional would be y equals mx, and an example of non-proportional is y equals mx plus b. So those are just some things about proportional or non-proportional. I'm just making sure that I didn't forget anything. When it talks about, distance traveled is equal to, So we have proportional, has to go through the origin, it has to be linear, and it's going to be in the form of y equals mx. A non-proportional is not going to go through the origin. It doesn't have to be linear. It might be linear, but it doesn't have to be linear, whereas proportional has to be linear. And then it's going to be in the form of y equals mx plus b. It's going to have a y-intercept. That's why it's not going to go through the origin, because it's going to have a y-intercept. So let's get to some examples. Example 1. Write an equation to determine the number of liters in any number of quarts. Describe the relationship in words. So I have a chart. I have quarts and I have liters, and this would be like my x and this would be like my y. So in order to write an equation, I need to find the slope, the change in y over the change in x. So you could use your calculator. I have my calculator right here. And I would subtract 4.75 minus 3.8, and I get 0.95. And then I would subtract 3.8 minus 2.85, and I get 0.95. And then I would still get 0.95. So the change in y values is 0.95. It's going up by 0.95. The change in x values, if you subtract, 5 minus 4 is 1, 4 minus 3 is 1, 3 minus 2 is 1, and those are going up by 1. So my slope is 0.95. And what that means is that there are 0.95 liters per quart. 95 liters per 1 quart. So that's what the slope means. I've interpreted the slope for you. Now that I have my slope, I can write my equation. And if you would like to pick a point to put it in point slope, I'm just going to pick that first point. So y minus 0.95 equals the slope x minus 1. So again, I picked a point and I put it in point slope. Y minus 0.95, and then I'm distributing. I'm going to add 0.95 to both sides, and do you see what's going to happen here? Negative 0.95 and a positive 0.95 are going to cancel, and I'm left with, here is my equation. So this is a proportional relationship. It's also a direct variation. And what that means is for every 95 quarts, 0.95 liters per every quart. So now the question is, how many liters are there in 8 quarts? So 8 quarts represents an X value. So I'm going to substitute that in. And my answer, 0.95 times 8, you can use your calculator, but it's about 7.6 liters in 8 quarts. About 7.6 liters in 8 quarts. So I wrote an equation, and then I solved it. Say, hey, Ms. Monroe. All right, number 2. The total cost of tickets to a school play is shown in the table. So we have our number of tickets, T, and our total cost, C. Part A, write an equation to determine the cost for any number of tickets. So not just 1 through 4 tickets, but any number of tickets. And describe it in words. Use the equation to determine the cost for 15 tickets. So we have 2 things. We're doing it just like example 1. I need to find the slope. So I'm just going to take 2 points. I'm just going to take these 2 points. And I get 18 minus 1350. That's the change in y over the change in x. So my slope is 4.5. And what that means is $4.50 per ticket. Because I have the slope, I can pick any point. And I'm just going to pick the first point. I'm going to put it into point slope. Y minus 4.5 equals the slope, x minus 1, because this is your x and this is your y. And then I distribute. And then it's similar. We're going to add 4.5 to both sides. Those are going to cancel. Y equals 4.5x. So there is my slope. That's my equation. Part run, write an equation and describe it in words. So the way you would describe it is you would say it's $4.50 per ticket to the total cost. Total cost is $4.50 per ticket. That's how you would describe the equation. We would include total cost because that's what my y variable. The total cost is $4.50 per ticket. And then the last part says use the equation to determine the cost for 15 tickets. So 15 tickets would be my x value. So I substituted in 4.5 times 15. And my answer would be $67.50 for 15 tickets. Okay, and this one is also proportional because there's no y-intercept. Well, the y-intercept is 0, goes to the origin. All right, example 3. The total distance Marlon ran in 5 days is shown in the graph. Write an equation to determine number of the miles ran y, so the miles is y, after any number of days x. So again, we're writing an equation. Then determine how many miles he ran after 2 weeks. And so this is the time in days. So 2 weeks would be like 14 days, but we'll get there. So just like we started the others, we need to find the slope. And you can take any 2 points. I'm just going to take these first 2 points. So I'm subtracting y minus y. So 7 minus 3.5 and 2 minus 1. So my slope is 3.5, and that means he runs 3.5 miles per day. Then I'm going to put it into my equation. Whoops. I'm just going to use that first point. Y minus 3.5 equals the slope, x minus 1. And maybe by now you've seen the pattern that if it starts like this, then it's going to end up canceling out. Plus 3.5. So y equals 3.5x. The total number of miles that Marlon runs is 3.5 miles per day. Determine how many miles he ran after 2 weeks. So that would be 14 days. So 3.5 times 14. 3.5 times 14. I'm just typing it in my calculator like you can do. And I got 49 miles after 2 weeks. Okay. So all three of these examples were proportional. All three of these examples were y equals mx, and we found the slope, and then we put it in point slope. So on the back, we might have some questions that are non-proportional. I don't know. So let's just see. Example 4. A gym charges an annual membership fee of $10. I just wonder what my time is. Hang on one second. An annual fee of $10, but you must pay $9.50 for each visit. Write an equation to determine the cost. Is the relationship proportional or non-proportional? So again, it doesn't give us a table or a graph, so we have to use the information. I see a membership fee of $10, but you must pay $9.50 for each visit. So whenever you see like each visit or per visit or something like that, that's going to be your slope and any cost for any number of visits. So y equals mx, and then let's see if we have a y-intercept. This membership fee, you have to pay even if you don't go visit. So this would be your y-intercept because you have to pay it. It's like your starting amount. So y equals 950x plus $10. So here is our equation. So we wrote an equation, and then part B, is the relationship proportional or non? And it's not proportional because it has a y-intercept of 10. It's not proportional because the y-intercept is 10, not 0. So that was the answer for number 4. Okay, number 5. Paul earns $25 for grooming a dog plus $18.50 a day for boarding. So hopefully that $18.50 stuck out at you. $18.50 a day. So that's going to be your slope. And then $25 for grooming. Well, you only groom a dog once per day. You don't groom a dog every day. You only groom a dog once in a while. Write an equation to determine the amount of money Paul earned, M, so they're wanting us to use M, for grooming a dog once and boarding number of days, D. So he's grooming once and then boarding D days. Make a table, determine his earnings for 5, 6, 7, and 8 days, then graph. All right, so first we need to write an equation. Except we're using writing equation to determine the amount of money Paul earned. Okay, so this would be M. And then the number of days. So total money, and then our slope was $18.50 plus 25 for grooming. So my slope was $18.50 and then the original $25 for grooming. Make a table to determine his earnings for days. So 5, 6, 7, and 8. So you would just plug these in to get your values. You would just plug those in to get your values, and I've already done this one. So where did I do this one? Okay, well now I can't find it. So $18.50 for 5 days plus 25 is $117.50. Is 136. I'm plugging in these numbers into the number of days. And then I can graph over here. So my x-intercept is number of days. And my y-intercept is money earned. So 5 is going to be somewhere around there. So 120, 36, 54, and 8 would be 173. Now, this little, you see that little squiggle? That is just math shorthand because they didn't want to list out 0 to 120. So when you see that, just know it's kind of like they just shrunk that part of the graph that wasn't going to be used. Because it just asked us to start at 5 days. And then it knew it was going to be a lot of money. So I'm not even going to extend. I'm not going to draw an arrow right here. I'm just going to stop there. So we made a table, and then we graphed the ordered pairs. Okay? So you try number 6, pause it. I'm going to look at my time. You try number 6 and then tell me, or then you can check the answer when you get done. All right, Chloe jumps. Her average rate is per minute. Okay, so there is no y-intercept in this one. So y equals 225x. Number of jumps in any minutes. And so it didn't tell me what variables to use. So I'm just using y and x. Because it says jumps per minute, I know that's my slope. And then I know per minute is my x. And the number of jumps would be my y. So write an equation. So here's my equation. Make a table, 1, 2, 3, 4, and 5. And then number of jumps. So in 1 minute, I know it's 225. In 2 jumps, it's 450. 675, this was the one I already did, 900, and then 1,125. So there's my table. And then I need to graph my ordered pairs. So down here on the X, I have number of minutes, and that's your time. And then over here I have jumps. So since I'm only going to 5, I'm going to do these 1, 2, 3, 4, 5. And then I'm going to count these by 200s. I did 200s. 200, 400, 600, 8, yeah. 200, 400, 600, 800, and then, oh wait, no, maybe I didn't. 2, 4, 6, 8, 10, 12. That's 1,000. All right, well, we might be off our graph a little bit. 1 jump is 225. 2 jumps is 450. 3 jumps is 675. 4 jumps is 900. And then 5 jumps is going to be up here at 1125. And as you can see, it is a linear equation, and it goes to the origin, so this is proportional. Okay, we are going to practice more. This, again, is titled Representing Relationships and Writing Equations.